calculus differentiation. Now, calculus is just studying the rate of change of one variable with respect to the other variable. But as a UTM, you don't need all of those. So here we talk about differentiation. Differentiation, you can differentiate using the first principle or general rule. As you do UTME, you need to use the general rule in order to ace your speed. Now, what does the general rule state? It said that assuming I have A and this A has power of n. If they tell me, okay, find the y over the s of this particular expression, this is going to be equals to, I'm going to use this n, you bring the power and multiply it by the base. I will now have n multiply. In multiplication, we use dots and represent multiplication multiplied by the base. Now, this same power here I brought down, we still remain here, but now I'm going to minus 1 from it. This is the general what rule for differentiation. For example, let's differentiate 2s raised to power 3. Where is my base? This is it. Where is the power? This is the power. So now let's find the y over the s. This is furthermore equals what? As I brought this power down, I'm going to bring what? 3 down to multiply what? 2s. I'll put a dot there. And what again? I'm going to use 1 and take away from 3. I'll minus what? 1 from the power, which is n. Are you getting? Now this is furthermore equals to 3 multiplied by 2s is going to give us 6s. And now the power we are going to have what? 2 left. This is the what? Dy over ds. I have differentiated this. Now, if you look closely in this general rule, you cannot see anything like 2, 3, 4, 5, and 6. You can't see those numbers. Hence, any constant here is represented as 0. For instance, differentiate 2, or let's use s raised to the power 4 minus 2x minus 2s plus 5. To differentiate this now, that is find the y over the s. What are we going to do? I'm going to differentiate this, and differentiate this. Now, because I know that any constant is 0, this 5 here is a constant because it does not have unknown variable, which is the s. So this becomes 0. I'll only differentiate this side. 4 coming down here, I'm going to have 4s minus 1 from 4 element 3 minus 1 is here. 1 coming down multiplied by 2 is still going to give us minus 2. And now, if I should take away 1 from this invisible 1 here, it remains 0. S raised to the power 0 is 1. 2 multiplied by that 1 is going to give us what? Negative 2. These are what? Differentiated what? Of this expression. Are you getting me? Now, mostly, as you can see, this that I'm doing here is different from the first one that I've solved. Why is it so? As the science we have in mathematics has expanded, so has calculus differentiation expanded. For instance, we have addition, which work hand in hand with subtraction. We have multiplication, we have division, we have power. We also have trigonometry. We are going to be finding sine rule and less of them, and many more as well as we could have in mathematics sign. Now, if you look closely, these parameters here or these signs here in mathematics give us a broader expression of calculus. Hence, from here, if you're talking about addition and subtraction, we talk about derivative. Talk about the derivative of sum. All right, is still the same thing with negative. Derivative of what? Sum. Talk about addition and subtraction. If you talk about multiplication, talk about derivative of product. Derivative of product. If you talk about division, we talk about derivative of quotient or quotient derivative. Or quotient derivative. If you talk about power, we talk about compound derivative. Compound derivative. If you talk about trigonometry, talk about differentiation of what? Trigonometry. Differential trigonometry. Are you getting me? Now, in this video, we'll be looking at derivative of sum. All right, this is the first class, so I want to explain a little bit. So, derivative of sum, it means that let's use v and u for example, and we're going to be using it throughout the episode of this calculus class. If v and u are variable, for example, v can be 2, 3, 4, u can be 2, 3, 4. Those are what? Variable. Now, where are we using v and u? For instance, if v is to add with what? U, if they are adding themselves, we know that they are what? Derivative of what? Sum. Now, according to the rule of derivative of sum, if you are asked to find the y over ds of v plus u, it means that you're going to differentiate v, which now become the v over ds. You're going to differentiate v and you add it with a differentiated u, that is the u over ds. What does that mean by differentiating? If you're asked to differentiate, you simply what? Minus 1 from the power, bring it down. You bring the power down and minus 1 from the power, and you what? You work it out. All right. So this is what? Derivative of a sum. Now let's quickly look at this example here before we look at the work JAMB past paper. So here we have differentiate 2x cubed minus 3x squared plus 34. Find the y, or given that 2x cubed minus 3x squared plus 34, find the y over ds. So they are simply saying you should what? Differentiate. Now, if you look at this, how do you know that it is in sum? This is, they are adding each other with, they join each other with a negative and a positive, which tells us that it is a what? Derivative of sum. And according to the derivative of sum, we are going to differentiate each of these and we add it what? Together. You can add it together with the sign that is separating those variables. So because this is negative, I'll do a subtract. This is positive, I'll do a subtract it. Now let's take this as what? V. Let's take this as U. Let's take this as S. So the alphabet keep on what? Going. Just use it to remember the what? Formula. Now to find the Y over the S, according to that rule, I'm going to differentiate what? V, which is what? dv over what? ds. Differentiate U, which is what? dv over ds. And I'll minus it from what? Differentiated d. I'll differentiate this one, it becomes what? du over ds. I'll differentiate 34. It becomes add with what? ds over what? ds. Let me use another alphabet so I don't be confused. Let's use t. It now become what? dt over ds. Are you getting? So I'm going to differentiate this now. This is equals to 3 coming down becomes 6, because 2 multiplied by 3 is what? 6. And minus 1 from here, I'm going to have 6s raised to power 2. I have done dv over ds. Differentiated this. Now minus 6 from what? 2 come down to multiply by 3. So going to give us what? 6, negative 6. And s, now 2 minus 1 from me, remaining 1. S raised to power 1 is 1. So just s have represented s raised to power 1. Hence, I have differentiated this, which is what? du over ds. So I'm also going to differentiate 34. And differentiating 34, any constant is what? 0. So differentiating t now means that here is plus what? 0. And all of this plus 0 is still going to give us what this is. And these are what? Differentiation. Are you getting me? Now let's look at question on UTME. All right, I hope we can differentiate this with gradness. This is a UTME question. Now, once we want to do the y over there, that means differentiate. If something, let me say a is to the power of n, to find the y over ds, you remember what? We are going to bring down n to multiply by what? A. And the power is going to, we are going to take away what? 1 from it. So now, to differentiate this expression, I want to differentiate 3s to the power 2. 2 is going to come down. I'll have 6s. 2 minus 1 is remaining power 1. S raised to power 1 is the same thing as s. Now, plus 2 will come down, will give us 4. S to the power 2 minus 1 will give us s raised to power 1. S raised to power 1 is the same thing with what? S. Add it with what? Now, here I don't have power, but I have invisible power of 1. This invisible power of 1 coming down to multiply 6 will give us 6. Now, when you use 1 and minus by that invisible power of 1, because this is according to the word general rule, I must minus 1 from the power and also bring the power down. Are you getting me? 1 minus 1 is going to give us 0. S raised to power 0, like anything raised to power 0 is 1. Now, when 6 multiplied by 1 is still going to give us what? 6. So we just leave it what like that. Now, differentiating of a constant, like you can see, there's nothing like 2, 3, 4, 5, 6 in this formula here is equals to what? 0. So 1 is 0 plus 0. If this plus 0 is still going to give us this particular what expression. So these are what? The y over ds. And this is in option number 6. Now, this I want to teach you something more before we go further. This here now is what we call f prime. F prime is what we call what? F prime. In some question, they will say find the find the 2y over ds. They'll say to find what? The 2y over ds. This one is now f prime prime. It means that if you differentiate one, you also differentiate again. You differentiate what? 2 times. For example, this one is equals to what? The y over what? Ds. Now, to find the 2y, if assuming they say find the 2y over ds, the 2y over ds means after I've differentiated this first one, I will differentiate it again. So differentiating this again, now I'm going to say that take away 1 from invisible 1 is 0. X raised to the power 0 is 0. What remains here is what? 6 plus. Take away 1 from invisible 1 is 0. X raised to the power 0 is 0. 6 now x raised to the power 0 is 1. 6 multiplied by that 4 multiplied by that 1 is going to give us what? 4. Now any constant differentiation is what? Is equals to 0. Add this plus 0 is going to give us what? 4 plus 6 plus 4, which is going to give us what? 10. So this is now what? The 2y over ds of this expression. But in the question, they say we should find what? The y over ds. They have question like that. That's why I brought it up. Now, the next question here, look at it very well. It says if y, we have if y equals 2 over 3 s to the power cube minus 4 over s. Find dy over ds. And I have options. So this, I have option A. My option A is it 3s raised to the power 2 minus 4 over s? Or is it B, which is 2s raised to the power 2 plus 4 over s squared? C, is it 3s raised to the power square plus 4 over s raised to the power 2? Or is it D, 2s raised to the power 2 minus 4 over s? So which of these is the answer? Can you solve this? If you can, pause the video and try it. So here, now to differentiate this, as you can see, we have s as a denominator. We are going to make this s to come up here. What are we going to do? Now, I will not differentiate first. Let me say, I will write everything. Now, minus this s coming up here. This division is going to form a power of -1. So that s coming up here, I have 4. S coming up here will now become 4 multiplied by s is going to give us 4s. This division will now become a negative power of 1. Just like from the law of indices, a raised to the power -1 will be written as this -1 on top. You now form a division, and the a will become a base, and this one will be up here. It's still the same thing with this. Now, to differentiate now, we're going to say dy over ds is now equals to, from here now, this is the power. I'm going to bring it out to multiply by this. I will now have 3 dots. Remember, we use dots to represent multiplication in calculus. 2 over 3, and I have s to the power 3 minus 1. Now, in this side, I have negative bracket. This my -1 will come down here to multiply by what? Multiply by 4 will give us what? -4. Now, -4 to negative is going to give us plus 4s raised to power. I'm also going to have -1 and a -1. This -1 is from here. Why -1 is from the law of what? General rule in differentiation, which says if a is to the power n, to differentiate the y over ds, you use n and bring down, and the power n you minus 1 from me. That's what I did there. Now, finally, the y over ds is equals to 3 will cancel 3. I'm having what? 2 multiplied by s is going to give us 2s, and here 3 minus 1 is going to give us 2, plus here I'm having negative 1 is going to result to negative 2. I have 4s to the power negative 2. Now here, this is our what? Final answer. But if you look at the option, you're going to see a different thing which we have as this fraction. So because of that, we need to still convert this, like using the law of indices. How can we convert it? Using the law of indices. Using the law of indices for this particular expression here, like I said, this negative here, negative can form a what? Fraction. So to do that, this answer is furthermore equals to 2s to the power 2 plus 4. Now, this negative here is going to form a what? A division. Let me remove this. It's going to form a what? A division. And this s is going to be at the bottom here. Now, if this negative form this division, what is remaining here is what? 2. So this 2 is now going to come closer to what? S, which will have it as s squared. Now remember, we have 4 on top here, which is multiplying. So 4 is going to be here. Now, according to law of indices, it should be 1 over what? A. But here it is 4 over s squared. So if I should put even 1 over s squared, 4 multiplied by 1 is going to give me what? 4. So the correct one is now 4 over what? S squared. What did I do? I just use this one, bring back this s down here, and this one become a what? This minus become a what? A division sign. Now this is our final answer. If you look from the option, you have it as 2s squared plus 4 over s squared. Now I want you to try this expression. Try this question. It says if y equals 3t squared plus 2t squared minus 7t plus 3. Are you getting me? Find the y over this. Find the y over the t. Sorry, I mean to say what is here is the t, because the unknown variable we have here is t. So find the y over the t. That is with respect to what? T. They were given option. Okay, find the y over the t at t equals to negative 1. This one is very simple. Very simple. At t equals to negative 1. So you are given option A. Is it negative 1? B, is it 1? C, is it negative 2? And then D, is it 2? All right, is negative 2? Is it 2? So what are you going to do here? You're looking for the y over the t. So you're going to differentiate this, and you'll say at t equals to negative 1. So you're going to differentiate it just like the way we used to differentiate. After differentiating, let me say you get your answer to be 2t plus 3t plus 5. If this is your answer, after you have differentiated the y over there, that is bringing the power down and minus 1 from the power. After you have done that, this becomes your answer. For instance, you're not going to substitute t for negative what? 1. So that here becomes 2 bracket negative 1 plus 3 bracket negative 1 plus 5. So if you open the bracket, you work it out. This is not what you're going to have if you do it. So this is how you're going to do it and get your answer. Now, after you have done it, let this be your number 1. Put the answer in the comment section. The second one you have to do for me is solve this. I'm going to bring this one from my memory. Solve 36x over x squared plus 2s. So differentiate this. Put your answer in the comment section. No option. So differentiate this. Put your answer on the comment section, guys. All right. So in our next class, we're going to talk about this is actually class 1. So in our next class, which is going to be class 2, I want to talk about differentiation of products and the JAMB question that you're going to have. So make sure you click the notification bell and subscribe if you have not. Please like this video, share to your friends so that they can also learn from this. Bye bye.